Hello viewers, it's another time and we are listening to Indices. In fact, today I am privileged to share with you one application in Indices, okay? Yeah, so our problem is going to be under Indices. Don't forget, there's a problem. We have 2a raised to the power half, then b raised to the power what cube, or into bracket raised to the power what 4. Then we have 4a raised to the power what 6 and b raised to the power 2 or into brackets negative half. Alright, there's a wonderful problem, and don't forget it's just an application question. Don't forget, I do keep on telling you that anytime you come across a question or any problem in mathematics and you want to solve it and get a correct answer, what you need to do is to understand the concept of the question or the concept of the problem. This problem specifically is from indices, and don't forget, in indices too we have certain rules and property that guides us in what solving or dealing with our problem. Alright, so today I'm going to present with you some basic rules. I've titled them Rule 1 and also Rule 2 separately. Alright, so this is the first rule, and normally it is termed to be what product of powers. Okay, it is termed to be product of powers. Yes, look at the rule. We have a raised to the power m going to bracket raised to the power what n equal to, what can you see from this rule? Don't forget, it is the n which is multiplying the m. Don't forget, anytime you see an expression in the indices like this, what you need to do first is to use this power outside the bracket to multiply the other power in the bracket. Okay, to give you this. Normally we call it what? Product of what? Powers. Meaning we are multiplying the powers. Is that clear? Then the next rule that we will look at is this one. Don't forget, this one, it is a raised to the power what? A negative power. Don't forget, it is a negative power. In indices and also in every mathematics question, we want our answer to be positive. And before we can deal with this expression, anytime you come across a problem in this form, what we need to do first is to change this expression to this form, okay, to become 1 over a raised to the power what? N. Don't forget, this time we have no more negative n, but rather what? N. Because of this thing, we reciprocate this rule. We call it what? A reciprocal what? Rule. Is that clear? And I'm sure you understand it correctly. Alright, yeah, so I've simplified the rule for you. These are the rules. We have a reciprocal rule and also a product of what? Powers. And I'm sure by now you understand. So we are going to base on this property and rule to tackle our problem. Okay, yeah, so in the first place, let's first look at the problem. This is the problem that we're talking about, which is 2a raised to the power what? Half, then b raised to the power what? Cube, going to bracket raised to the power what? 4, multiplied by the expression 4a raised to the power what? 6, then b raised to the power what? 2, all into bracket what? Negative what? Half. Now if you can bear with me, you can see that this expression, this one, it's similar to the product of powers, okay, and this expression too is in the form of the second rule, right? So before we tackle this problem, what we need to do is to check the rule again. Initially I told you that anytime you see an expression in that form, we have our first term expression in this form, which is a raised to the power what? N. So what we need to do to that problem is to multiply the n throughout everything bracket, okay, but not rather the base, but the exponent. We multiply exponent rather. And the second expression, this one that I'm talking about, because of this negative, we must change the whole of this expression into what? A fraction. And I'm sure you understand the reason why it needs to be in what? Fraction form. Yeah, so don't forget, this first term is similar to the first rule, and the second term is also similar to what? The second rule. So what we are about to do is to, using the first rule to simplify the first term and also the second rule for the second term respectively. So this, the expression we have here, don't forget, it is this expression that I've expanded here. Don't forget, initially I told you that what we need to do is to use this 4, the exponent 4, to multiply the powers in the bracket. So this 4 automatically will multiply the half. and also this one will also multiply the 3, and I'm sure you understand. Yeah, so looking at this, don't forget, and anytime you see a constant figure like this in indices, don't forget it is root to the power of 1, and I'm sure you by now you understand that concept. Yeah, so we have that simple 2, that constant 2, don't forget it is root to the power of 1, so this 4 will multiply, this 1 which is not present at this time here. Okay, so it becomes 2 raised to the power of 4. Anytime you see a dot in this expression, it means multiply. Okay, so we have a dot. Don't forget this a raised to the power half will multiply the 4. So it becomes what? A raised to the power of half times 4. Bracket close. Then we have b. This b. Okay, yeah. So b raised to the power 3. So b raised to the power 3. It is also going to multiply by 4. And I'm sure you understand up to this point. Now let's bring our multiplication sign here. Alright, so let's continue. Yeah, so bringing our multiplication sign here, it becomes the next expression. Don't forget, initially we are going to apply the second rule here. For the second term, because of the powers of this this power in the question was negative in this form. As you may know, this negative power. Because of that, this expression we need to what? Change it. This expression we need to reciprocate it, okay, based on the second rule, right? Yeah, so based on this second rule, anytime you have a negative power, what we need to do is to reciprocate what? The expression. Is that clear? So this expression, instead of expanding it directly, what we need to do is to apply the concept. So we reciprocate it first. Is that clear? So it becomes 1 over bracket open 4 a raised to the power what 6 b raised to the power what a square, and all into bracket what now positive half. Is that clear? No more negative half again. That apply rule 1 throughout. You see, after doing this thing, then the next step which follows, we apply the 1 throughout. Is that clear? Yeah, so since we are done with this first expression, and I'm sure by now you understand the reason why we have this. Don't forget that I have used the first rule to simplify this one, and also the second rule to arrange the expression in this form in a fraction. Don't forget, because of the negative power of half, now it has become positive, and rather it's supposed to be in the form of fraction, so 1 over the expression, a positive 1. Alright, so the next step that we need to do is to apply the concept of first rule, the one that we are talking about, throughout. So we need to tackle the based on the first rule, that the product of power is throughout. So now still remain 2 raised to the power 4 dots. Don't forget, multiply by a raised to the power what half times 4, then b raised to the power what 3 times 4, or bracket what close. Okay, multiply by the expression. Yes, let me push it up a bit. So multiply by the expression. Don't forget, still 1 over 4 raised to the power 1. Don't forget this expression. Now we are coming to apply the first rule again, this second expression. It will multiply the 4. Don't forget that in indices, this constant figure is having a power of 1 here. So it becomes what? Half times what? 1. So it becomes like this. 4 raised to the power half dot multiply by the expression a raised to the power what 6. So 6 times what? Half. Okay, like this. Then we have the constant b also there. So b raised to the power what 2 times the half. And I'm sure by now you understand. Now let's simplify. Is that clear? So this raised to the power 4 give you what? 16. You can just pause the video and check that in the calculus. Okay, so then multiply by the expression a raised to the power. Don't forget, anytime you have half multiply by 4, you get what? 2. Don't forget, we are simplified. So 6a raised to the power 2, then the b, you check that 2, 3, 4. Don't forget, 3, 4 gives you what? 12. Then multiply by the expression 1 star 1. And one thing I would like you to know is that we are doing indices, and anytime you are solving indices question, what you must do is to all your values should be in the simplest form. The term indices simply means the simplest form that the figure should be. So when you check this 4, it's not an indices. Why is it that 4 is not an indices? Because it's not in the simplest form. So if you want 4 to be in the simplest form, what you need to do is to what? Break it down to 2 raised to the power what? 2. Don't forget that 2 raised to the power 2 also gives you what? 4. So this thing I have written down, or I've presented that in bracket for you to understand that this 4, I've done something to the 4. I've expressed it in indices, okay, initially, just for you to understand. Then don't forget it is raised to a power of what? Half. Then there's the power. Also, let's simplify the a, okay, so multiply by the a raised to the power what? Don't forget 6 by half give you what? 3, okay. Yes, then the b, don't forget anytime you have a 2 multiply by half, this 2 will cancel this one, leaving 1. Don't forget the 1, we don't normally present it in our expression, okay, and I'm sure you understand that now. Yes, now this expression still remain in our solution aspect, and also multiply by the expression 1 over 2. This time round, this 10 half will multiply the 2. So anytime half multiply 2, don't forget you get that constant figure. So these times, don't forget I've done it straightforward here. I should have presented it here for you to see, but half time this give you what? 1, okay. That's why I wrote, the power is 1 anytime. So 2 raised to the power 1 equal to what? 2. Is that clear? Yes. And still we have a here, okay. So we have a raised to the power what? 3, then constant b. Alright, since we have our expression like this, what we need to do is to, yes, can you pause the video and tell me the answer? Can you tell me what we need to do at this point? We've reached this point. What do you think we should do next? What we need to do is that, don't forget this expression is in fraction, because 1 over this 2a raised to the power 3 by b, okay, it's in fraction. So what you need to do is to use this figure. We should use this figure, all of them in the brackets, okay. We should use them to multiply the 1. So when you use that to multiply the 1, this will become what? A numerator, and this expression becomes what? A denominator. So applying the division rule, and I'm sure by now in the law of indices you know that we have a division rule, and it states that to divide a number written with the same base, what you need to do is what? To subtract the exponent. Is that clear? Anytime you have two values in indices and you are comparing, they have the same base and you are dividing, also what you need to do is to check the exponent and also subtract the exponent, okay. That's the division rule. Yeah, so since we have this, what you need to do is look at the system. We have 2, just compare them before you do that computation, okay. So we have 16 and 2. How many times can 16 goes to what? How many times can 2 go to 16? Yes, you get something 8, okay. Then look at the a. We have another a here. Now compare the 2. Don't forget you are dividing, still indices. So we are applying this rule, okay. We are applying the boldly written text here. The rule says that to divide a number written with the same base, so we are dividing this a square and a cube. They have the same base. The rule tells us that we need to subtract the exponent. So we have a square and this one a cube. So it becomes 2 minus what? 3. I intentionally didn't prove that in the subsequent solution, but I'm sorry, and per the explanation I'm giving, I'm sure you understand. Yeah, so we have 2 minus what? 3. Is that clear? You'll get what? Something like a raised to the power negative 1. Okay, then the b. Don't forget the b is b raised to the power what? 12, and we have b raised to the power 1. Don't forget then I do keep on telling you this, that anytime you have constant figure there, what shows is that it raised to the power of 1, but normally don't write. So this tells you that it's 1 here. So since you are comparing the b, it becomes what? B raised to the power what? 12 minus 1. Don't forget, still we are using the rule, so it becomes what? 11. So a multiply 8 multiplied by a raised to the power what? Negative 1. B raised to the power what? 11. Yeah, so this is a final solution to the problem. Initially, this was a problem, and I just want to wrap everything up for you. Don't forget, it's an application in indices, and I've already instructed you that anytime you have such questions in this form, what you need to do is to base on the rules and properties in indices and tackle this problem. So, viewers, what I'm telling you at this point is we have a product of power rule and also a reciprocal rule. The product of power occurs when you have expression in this form. Is that clear? That one, the powers, you're going to use the power outside the bracket to multiply the power in the bracket. But it should be everything in bracket, okay? If there are five, expression here, each of them is having a base in the power. Use this, this n outside the bracket to multiply everything. And also this a. When you do that, you must get expression in this form, meaning a raised to the power what? Mn. And anytime you see mn in this form, meaning it is multiplied. The same thing is, we have also a second rule. We call it a reciprocal rule, but it's a property. Actually, we have the rules in indices and also properties in indices, okay? So, since it's like this, a raised to the power what? Negative n. What you need to do is, in indices, we don't deal with negative numbers, okay? So what you need to do is to change it to positive. How can you do that? By dividing. So dividing, it becomes what? Anytime you have, even if it is 100 raised to the power, negative 100 look, what you need to do is to what? Becomes 1 over 100 raised to the power that number, but it should be what? A positive like this, okay? Yeah, so now we apply. So this is our problem. So we apply the secondary reciprocal rule here because we have a negative power. So we need to change it to become what? 1 over what? The expression, but this power should be what? A positive one. And directly we can use this 4 to expand everything in bracket. Don't forget that we use the 4 to multiply the powers in the bracket, and don't forget we have 2 raised to the power 1, but the 1 I didn't write it there. So you as a student need to master, need to solve more examples and know that anytime I have an expression in this form, it is supposed to be in this form. Alright, then you apply all the rules. When you do that, yeah, of course, you will come and arrive on this this expression as our solution. Right, thanks for watching, and I really appreciate your efforts to join me with this discussion. And in case still I'm called Dennis Asamoah Ama, and you can follow me on all the social media, including Facebook, Instagram, and also TikTok. But specifically, I use different names, okay? Yeah, so when you go to TikTok, you can search for @treasure, okay? @treasure. You see me say treasure. I pray I'll just write that for you to have access on. And also when you go to Facebook, the name still remain Dennis Asamoah Ama. Though I have an official page, so and I have included a whole lot of details over there too, and you can also access that too. And also Instagram, you see me Dennis Asamoah Ama also. Yeah, so in case you have anything in your mind, just feel free and drop that in the comment section. I just want to know your ideas, okay? Yes, and in fact, let's build our capacity and also improve more towards life, okay? Yes, alright, thanks for watching. I really appreciate it, okay? I'll see you next time.